Hello, and welcome back, Life Science Richmond City Public School students. Welcome to week 1, day 2 of our Life Science virtual lessons. My name is Phyllis Wilson, and once again, I teach Life Science at Albert Hill Middle School here in Richmond City. And I'm so happy that you've taken out the time once again to come back and do a little bit of Life Science with me. So let's go ahead and dive right in. On Monday, I asked you guys to watch 2 videos and to make some observations. So in the first video here, this one was called Ocean Food Chains, and then the second one was called Feeding Frenzy. These videos were kind of similar, except that in the first video, it did show you some phytoplankton, it showed you some huge loggerhead sea turtles, and other types of fish that were kind of swimming around, and you could see that they were all trying to get different things from each other. In the second video here, Feeding Frenzy, what you should have seen was huge schools of fish that were working really hard together to try to find something to eat. They were fighting and hiding just to get to that food. And so this brings us to our topic for the week, LS6, B&D, and LS8A, energy flow and food chains, food webs, and energy pyramids. From this video, you should have been able to see that all living things want to get or need to get energy in order to stay alive. Some of them can make their own, and some of them, like us humans, have to use food in order to get energy. And that's what those turtles and fish were fighting to do in those 2 videos. They were fighting to get food and the energy that they needed to survive. I also showed you 3 pictures, on Monday. One was of Takis, one was an apple, and one was a cheeseburger. These are 3 items that as humans, we can use for food in order to get energy that we need to stay alive. So, how does energy get from the Takis or from the apple into our ecosystem? Well, that happens through the sun. So as the sun shines, various plants like the corn that is used to make Takis and apple trees, which are producers, are going to capture that sunlight and they're going to use that light energy in order to make chemical energy through the process of photosynthesis. I know you remember that. And they're going to use the energy that they make in order to stay alive. They have to carry out their life processes, which means they need energy to grow, to make new cells, to repair the cells that are damaged, to just adapt to their environment. That all takes energy. So they're using about 90% of their energy just to stay alive. But how does that energy that's left behind get into the rest of our ecosystem from these plants or producers? Well, we can see how it travels into the other organisms by using something called a food chain. And food chains show that the path that the energy takes as it goes from our plants or producers into the consumers that are going to eat these plants or producers. Okay. So if you look right here, we have our Takis that came from corn. And then we have an arrow that shows that the energy is going to leave from the corn and it's going to travel into the human, which is a consumer because it has to eat to get its energy. When we look at a food chain and we see like the word, the arrow, and another word, or pictures, arrows, and another picture, it is showing us that the path that the energy took. Because it's showing who ate what or who ate whom, sometimes it's called a feeding relationship. So we had 3 pictures in the beginning. We had Takis, we had an apple, and a cheeseburger. As organisms that are consumers, we can get our energy many different ways, and each of those ways can create its own food chain. For example, we can have corn to human when we're eating Takis. We can have apple to human when we're eating an apple. Or we could have grass and then cow human if we're eating a cheeseburger that comes from a cow. When we want to look at which order an organism ate, then we will use something called level or order of consumers. And this will tell us who ate first or who ate second in a food chain. So in the first 2 food chains here, you know that the corn and the apple didn't eat anything. You can't eat the sun. But the human was the first to eat in each of these food chains. So we would call this human a first level or a first order consumer. In the third food chain here, you see that the first to eat was not a human. It would have been the cow because the cow ate the grass. And in this case, the human would be a 1, 2, second level consumer because it was the second to eat in this food chain. You can also look at overlapping food chains because, as we said in the last slide, sometimes we eat lots of different things. So, as a human, as a consumer, in one situation, we might get our energy from the Takis or the corn, and it goes from the corn to the human. We also might choose to eat an apple, and the energy will go from the apple to the human. Or we might eat that cheeseburger that came from the cow, and the energy will have to flow from the grass to the cow and then to the human. So when we look at overlapping food chains or overlapping eating relationships, we call that a food web, multiple food chains interacting together. One other way that we can look at this is called an energy pyramid because it's shaped like a triangle, right? And so an energy pyramid will show you from a food chain basically how much energy is available on each feeding level in our ecosystem. When we look at our energy pyramid, the producers should always be on the bottom of the food chain because we're going to have the most energy in those producers, and therefore you should have the highest number of organisms at the bottom. And we know that producers or our grass is going to get its energy from the sun. 100% of the energy is available to the grass because it's getting it from the sun, which doesn't run out. So we have 3 pictures of grass here to represent that. And then from our food chain, what ate the grass? It was the cow. And so on our next level of our energy pyramid, we should have our cow and our cheeseburgers. Notice that we have fewer cheeseburgers than we have pictures of grass. And then what ate the cow? Well, it was our young human being here. So because he ate last, there will be fewer humans in this energy pyramid at the that are at the top. So when we look at an energy pyramid, we should have more organisms at the bottom than we have at the top. So at the top, you should see the least amount of energy available and the lowest number of organisms. Each level in this energy pyramid is going to be using its energy to stay alive. So the grass will use 90% of its energy, sending 10% to the cow. The cow will use 90% of the energy from its food, sending only 10% to the human. So less and less energy is available as you go from the bottom to the top of the energy pyramid. In addition, if you flipped it, and let's say, for example, you had 3 humans here and you only had 1 hamburger, then you could see that that would be a problem. What would those humans do? Excuse me. Once they ate that 1 cheeseburger, they wouldn't have anything else to eat. And that would offset the entire balance of our energy pyramid and our ecosystem, which would be a bad thing. Also, what would happen if we got rid of all the grass? Well, if there was no grass left in this energy pyramid, then the cows wouldn't have anything to eat. And then all the cows would die. And then if all the cows died, in this case, if we had nothing else there, then the humans too wouldn't have anything to eat. So all of the organisms in the energy pyramid, all of the organisms in the ecosystem, all rely on each other to get their needs met, to have enough energy to survive. So we just learned quite a bit about food chains, food webs, and energy pyramids. What should you do next? Well, to continue your explain portion of today, you should go to your student workbook and you should watch the Brainpop video on energy pyramids and fill in the worksheet that goes with it. After that, if you have time, there's a great Amoeba Sisters video there about ecosystems, energy pyramids, and food chains. And if you have a little bit more time after that, There's a Forest Ecosystems Gizmo, which is basically a virtual lab. You can sign into it using your Clever account, and it'll let you change the number of producers and consumers in your ecosystem to see how that affects the flow of energy. It even comes with a great lab sheet. And then on Friday, to make sure you're understanding all of this new information, you're going to complete the extend and evaluate portion by completing a quizzes and the Legends of Learning playlist. Once you've done those things, you'll have wrapped up your learning for this week, week 1 of our life science virtual lessons on LS6, energy flow in food chains, food webs, and energy pyramids. Thanks once again for joining us, and let's get to work. Have a good day.